Hi everybody, welcome to another session. This one will be on Introduction to Helm, and today joining me is Amit D'Souza. Amit, would you like to do an introduction, please?
Hey everyone, this is Amit D'Souza. I'm a co-founder of Odyssey Cloud, and today we are going to be doing Helm, where we walk everyone through how to get started with Kubernetes in Helm.
Okay, thanks. Yeah, take it away.
So today we are going to cover a couple of topics: why do we need Helm, an introduction to Helm, and Helm at scale. Because in production you're not going to run individual Helm charts. So the main reason we have Helm is Kubernetes has quite a few moving parts or manifests. So you have a separate requirement for your deployment, you have a separate manifest for your service, you have a separate you manifest for your Ingress. Helm helps packaging all those manifests into a more simpler setup so that anybody can provide and share their applications to other users very easily, and it'll be very simple to configure with certain default values already pre-configured. So if you look here, Helm is already a CNCF graduated project, and people have been using it for quite some while now. So mainly there are two applications which are used in order to deploy your applications. One is Helm and the other is Customize. Both of them work very well. There is also an option of using Helm and customizing it after that, which is the option I currently prefer because you can get the best of both worlds. That we'll cover some other day, some other time. If we talk about the architecture for Helm tree, so Helm tree has one Helm client and it talks to the Kubernetes API server. And this is in order to install the respective chart onto the Kubernetes cluster, which we are trying to set up. So it goes and talks to the chart repository once your client adds the respective repository to itself. And then when you say Helm install the Helm chart name, it installs the application onto your Kubernetes cluster. So most of your applications you will notice are present on Artifact Hub. Artifact Hub is like the GitHub for Helm charts, where most of your Helm charts of all your different users, whether it is something which is provided by, say, external DNS, cert manager, Bitnami related charts, all of them you should be able to find on artifacthub.io. If you want to install Helm, I basically use brew install Helm to install it, but you all could choose based on what OS you'll use. You all could use brew install, Choco, or any of the other scripts that are there for the Helm charts. Now, how do you add a Helm repository to the client? So one of the things which I can show you all is you basically run a Helm repo add harbor. So what this does is I can pretty much copy and run this. So if you can see, I'm running Helm repo add.
Can we show that in Artifact Hub? Maybe that might be a better explanation to go through the steps of why we add the repo and then install it.
Yes.
It might be a
Sure.
good visual for beginners starting out.
Yeah. So how we basically do it is we go onto Artifact Hub and we search for Harbor. So Harbor is a tool which is used to store your uh, repository images, Docker images, or Helm charts. So you could just basically use that in order to set it up. And what you need to do is, in order to run the Helm chart, you need to first add the repository, which is very straightforward. All you need to do once you install Helm is run Helm repo add on your terminal, and that installs the repository into your Helm. The next step, what you do is you run a Helm install release name. Now, when you are running the release name, what you have to do is Helm upgrade -- install. You run the debug in order to get a more verbose output. So in case of failures, you know exactly why it failed. I normally do a dry run at the beginning. That is in order to generate your respective charts. So what it does is it actually creates all the manifests that it's going to install onto your respective cluster, and you can actually view them and see if everything looks as you expected it. You give the chart release name, chart repo name, chart name, and version number. So the version is important because you don't want to install the incorrect version by mistake. And the version you can get from here. So if you go and look, you will find that your chart versions are mentioned here. And there is a complete tie-up between what chart is using which application. So if you want to install an older version, for example, say 1.13, you'll notice that the application version will change based on that, or the latest version has 2.4.0. So you have to mention what chart version you're trying to install. And
And it's
once you do
also
that,
just
you mention.
can we go back? I'll just show you. All of this is a bit scary, all of this writing. So if you click install on that button, you know, when you're trying out, this is all you need to do. So you don't need to worry about all of the other stuff if you want to just get going for your first time. And then you just simply copy, paste, enter, copy, paste, enter, and then that will the kube context that you're pointing to, so the Kubernetes cluster that you're pointing to, that will install it on that cluster.
Yeah. So one thing I would like to add to that is here you would notice that they don't mention namespace. So for example, if you don't have a namespace existing under what you want to install this, so when you run this, whatever namespace that is currently configured is where it will install it. So if you're on the default namespace, when you run this command as is, it will install it on default namespace. If you wanted to install it in a specific namespace, as well as create that namespace at the beginning, what you need to do is add create -- create namespace, and you need to mention the namespace or -n storage. And what that will do is basically ensure it installs it in that specific namespace. So once you basically are comfortable with this, we are going to run this command right now so that it shows you what do you see when I run it. Sorry, give me a second. Yes. So here you can see it basically said, I can't find the respective file, Harbor. If I change the file location, which is helm file.d / values / dev / harbor.yaml. So you can see it's preparing the entire setup, and then it goes ahead and installs it. Now, why do we need this harbor.yaml? So not necessarily you want to install your application as is, right? So I, for example, have configured my URL to my specific Odyssey Cloud URL, and I have basically exposed the ingress on my specific URL. So I have updated this so that you all can reuse this repository or setup to install Harbor, play around with it, put in your own URL, etc. But what I have configured personally is I configured this with my URL, but I also added cert manager so that certificates are automatically created for me. And what I get out of that is this. So once that was just the dry run, but I basically set this up where after you do the dry run, you just run the whole application, which is without the dry run. And what that will do is install the application. Once you run this successfully, that is going to give you this particular screen based on whatever domain you put in there. It's not compulsory to have an ingress, more specifically a domain. You can always expose it via IP addresses, etc., node port, but that is an option which you'll have. So the advantage or the reason to have a harbor.yaml is to customize your respective applications, because you might have different configurations that each individual might want to use. So once that is done, then you basically have installed the application. What you're going to do next is the next part. So what can you do with an application? You can check the history. So how many times the application was installed? Is there anything specific to it? So if I type Helm history, Harbor. Give me a sec.
Well, while we're waiting doing that, we've just got a couple of questions. So I'll chuck the first one up. So how does application version differ from chart version? So that was before when you showed in Artifact Hub the two different types of versions.
Yeah. So as I mentioned before, the application version is not necessarily the same. So in 1.8.0, I have application version 2.4.0. So people can upgrade their charts without really upgrading their application. And what I mean to say is, so there was a time where Ingresses changed their API structure and they changed the way it is configured. So if you are using an older version of API structure and then the new version came out in Kubernetes and the chart got upgraded, but the application stays the same, right? It's only your Ingress or your Kubernetes manifest that are getting updated. Your application doesn't need to change for that. So that is the main difference between the application version and chart version.
Thanks. And then there was another question about, is it possible to share the slides? Yes, I will get those linked in the background now. Thanks.
So as I mentioned before, you can basically see what is the status. So when we did run it the second time, we got an error and you can see that there is a history. So now I see number 1 says install complete, but number 2 says install failed. Cannot patch harbor ingress. Now this is another thing that you need to understand, that sometimes objects are not possible to modify, etc. And in case of any issues, one of the best things is, while I showed you the history, now I can show you the next step, which is rollback. So if I do have a failure in my chart and previously on my previous stage, it ran fine, but the second time it failed, now I want to ensure that I'm going back to the previous version. All I need to do is type in Helm rollback and release name. And And what that does is basically it rolls it back to the previous version. So right now it is currently rolling back the harbor version which I had deployed. And once that is done, it will go back to version number 1, which is this one. And the last and the final thing is, how do you delete a chart? So you just pretty much run Helm delete harbor, and you mentioned the namespace, it is therein, and that's about it. So see, rollback was successful. Let's run Helm history harbor again, and here you can see it's redeployed the version number 1. You can explicitly pass in what version you want to roll back to. So if I wanted to roll back, if I had like 10 versions, I could say roll back to version 5 or roll back to version 3, and that is feasible as well. And here you can see it's roll back to 1. And last but not least, you can just delete the chart as is. Now let's go to the next slide. So talking about, now that I've covered the basics about how you install a Helm chart, now let's go to the next stage. When you have your own application, you are creating your own Helm chart, right? And in such a situation, I think all of us have different setups. So this is one example of what I have. Say I have a Node.js application. What do I need? What are the components in Kubernetes? One deployment, one service, one ingress. If it's a stateful set, then you'll add stateful set. And there are many such other examples. Like Brad, do you want to walk us through some of the stuff which you may have worked through as well?
With Helm?
Yeah. So like in this case, I gave an example how if I have a Node.js application, I just have these 3 components, right? So similarly, your application, which you remember you created a stateful set, you deployed MongoDB previously, and you had to create a stateful set, etc., rather than just 3 factors. So basically what I'm trying to say is we have many more components that you can add, whether it's a deployment, a service, an ingress, backend config. There is loads of things, but I'm taking a simple example of just this. You all can go to this URL.
Yeah, pretty much any Kubernetes manifest you can make. Config maps are a really good one when using Helm, because those overriding values, it makes it so easy. You don't really necessarily need to know. If you're leveraging someone else's chart instead of making it from scratch, you don't necessarily need to know how to make a Helm chart. You can just, pretty much the beauty of it is someone else does the work, and then you just put your config parameters in there. So I see a lot of benefits from, like if we look at the Argo CD one, for example, that creates all the config map and customizations used for Argo CD. So like pretty much any manifest you can make is good.
And I can quickly walk you all through how many configurations that might be present within
if you type Argo, there it is.
So what you'll notice is, as he mentioned, right, there is lots of configurations and this. So you see that this is all in YAML format. So all the dots basically go on to the next line and you have to indent them. But there is all these options are available and present. It's up to you how much you want to personally configure your respective application. So
I'll just quickly interrupt. We've got a question. So the question is from Praveen. Thanks for asking. Where does the Helm history fetch the historical information from?
So all this information is stored within the API structure itself. So everything will be there present within etcd itself. And it's actually all the client is doing is it's going into etcd and fetching this information. So going back to all of this, what our next step is going to be is talking about actually creating your own Helm chart. If you want, you all can go to this URL. I have shared this repository so that you all can further understand or work with pre-made templates of Helm. It'll make it easier for you all to jump into the Helm creation world. So I will jump into the code at this stage. So creating a Helm chart and what the structure is. The structure of a chart has to be, you have chart. Within that, you have chart.yaml. You have values.yaml, which are your default values, which are already predefined. And Then you have your helpers.tpl. This is where you will define any functions that you want to create in Helm template. And these are just the manifests. So as I mentioned, I have three components: deployment, ingress, and service. So I have only these three YAML files.
Can you please go into
And
present mode?
your
Can you go into present mode, please? It
Sure.
makes it way easier to read. Thanks. That's better.
Yeah. So as I mentioned, I basically have the chart. I have the helpers.tpl, which will have your Helm functions, the components which you might need. So if you have a stateful set, that would add another file here. If you have a backend config, that will be another file here, and so on. Now, if you talk about the chart.yaml, this is where within the chart.yaml, your version is mentioned. This is the chart version, and this is where the app version is mentioned. And what you see on the website and Artifact Hub is basically pulling it out from these two locations, where it's pulling the version and the app version and displaying that on screen. The next part is helpers.tpl. This is where the respective charts are written, and I will show you all the function itself. This I'm just showing you all for a high level. You basically, your helpers.tpl have all the Helm functions that you want to create and that you will utilize within your Helm chart. So here I have defined a function called chart.fullname. What I have done is I'm doing if values.fullname.override does not exist, then do values.fullname override, truncate by 63 characters. The reason for that is kubedns has a maximum of 63 characters. This especially makes a difference when we are trying to create ingresses. So anything more than 63 characters will pretty much just fail. And the last alphabet of your respective name cannot be a hyphen. So you have to truncate if there is any suffix hyphen which is pending after trimming it down to 63 characters. Now, what is this? You would notice that there is a hyphen at the beginning and a hyphen at the end, right? So what do? They chomp white space. And the other thing we need to remember that chomping of white space is even a new line is considered as a white space. So if I have put a hyphen on certain other locations, I'm basically deleting any of the white space or new line characters present on it. So since this is a function, I don't really need it to print or do any new line characters, which is why I have pretty much chomped up or eaten up all the white space or trimmed the white space in all of these lines. After that, how do I declare a variable in Helm? I basically type in dollar and the variable name. When you're first creating the variable, you have to put a colon equal to, and then you can put in the variable value, or in my case, I have given it an option. So the default value will be chart name, or if values.name override is provided, then use values.name override in this case. Now, this is the second time I'm going to use the variable. You would notice now once it's defined, I can just use it as is. So here what I'm doing is if this dollar name contains my release name, then that is sufficient. All we need to do is truncate it by 63 and use it as is. If not, then concatenate both the values. So what I've done here is %s, %s. %s is the way you display a string. First you write %s and you put the variable name here. So my first %s is signifying release name, and the second %s is displaying the dollar name. And I put a hyphen in between both of them. And since we still have the limit of 63 characters, I'm truncating the 63 characters. And then we can't have a ending or lagging hyphen at the end. If by mistake, that turns out to be the last character, your chart will fail. So we have to trim the last hyphen as well. Now, going back to the code, I can show you all that I have multiple functions which are created in this particular case. One is chart.chart, and the second thing is chart.fullname. The third one is chart.name. I have created these three functions and I'm using them in multiple locations throughout my code. You will notice that they are present here. Chart.fullname. For the labels, I'm using chart.name. And for the chart, I'm using chart.chart. You don't necessarily need to have all these functions or labels. It's up to you how you want to create your respective application and what labels you might want to add to it. So actually writing the next part. So one thing that is important, or what you will notice inside a Helm chart, is this is how a Helm chart or the service.yaml would look. I will show you all the complete file as well, but at the beginning I thought I'll walk you all through this. It's pretty much what happens in the background is it's getting converted back into a Kubernetes manifest or a Kubernetes YAML file. And what that is doing is we basically mention API version, your kind, metadata. If you want to call a function which is present in your underscore templates dot your helpers.tpl, what you need to do is put in the double brackets, say include, and then the function name, and then you put in the dot. What the dot does is it's passing the scope. It's telling the respective function where the cursor is currently. And this particular cursor is specific to your values.yaml file, more specifically, as well as it basically is running through all the values.yaml that you have. And it passes whatever values.yaml that you have either pre-configured in the values.yaml or post you finish creating it. If you're provided any additional definitions, it helps you pass all those additional values here using the dot. So this is how you would call your function. And what does with do? With basically is passing, it's saying go into values, go into service, go into annotations, and specifically pass the scope to annotations. Sorry. Specifically pass the scope of this particular value to our respective application or Helm. And what it's then doing is it's just displaying the annotations which you have ended up putting there. It's converting it to YAML and indenting it by 4 spaces. So this basically temporarily moves the scope of your respective cursor to the respective location that you specify here. This can be, in this case, it's annotations because that's what I'm using here. That's what I want to display or embed into my Helm chart. But this can be for use for other portions as well, or other values you want to pass in. The next part is how do I directly select a value? If it's a normal string value, just values, service, type, and that's it. So that goes into your values.yaml and picks up that value. So if you go into values.yaml, you'll notice it goes into values, service, type, cluster IP. It will just put or embed the cluster IP onto that respective chart that we have created. And similarly for port, it does the same. Now let's walk through Ingress. You will find that Ingress, which I've created it, you would notice that I put in a lot of additional stuff. And the reason for this is I wanted to ensure that there's one single Ingress, which we can reuse multiple times. So say I have 2 domain providers. One is Google and one is, say, Cloudflare or AWS or any other ones. So using this particular Ingress template which I've created, you can pretty much just go into your values.yaml, put in this, but not just this. You can actually put in Ingress hyphen GCP and put in values specific to this. Along with this, you could reuse and say Ingress hyphen Azure. And what this helps you doing is you are basically not going and creating 3 different ingress.yamls, and basically ensure that you can reuse your code. And I've just modularized it so that it takes a range of ingresses. So even if I have 10 separate ingresses, it can use the same ingress.yaml, since I've created a for loop here. So now let me walk you all through Ingress. What I'm doing here is I get the respective values, which is present here. So it goes into values. You can provide more than one file of values.yaml. So if you have even further customization, you can create a new file of values.yaml and can reuse it, or provide 2 values.yaml to the respective Helm chart. I convert it to a string. I then store the parent template scope so that I know where the cursor can be. I then performed a regex to search for all the ingresses available. So as you noticed, if I put in ingress hyphen GCP or ingress hyphen Azure, it can go into each of those and extract those values. I then store that into ingress name. Now you notice this, I've called it range, and what that is nothing but a for loop. Now what I'm doing is regex find all searches for all the values present which have ingress hyphen cloud provider name. It doesn't need to be a cloud provider. This is a simple regex. It can be, you can call it whatever ingress name you want. I pass in the values itself. What is the string I need to search? On what string am I running the regex? And -1 is telling it how many responses, or if I find say 20, if you want us to return all 20 of those results, put in -1. Or you could specify how many results you want it to be returned. So say if you can put it 3, you can put it 5, it depends on you. But I keep it as -1 since I want to scan the whole values.yaml for all the ingresses available here using regex find all. What I'm then doing is storing all the entire list of values into this range called index.name. And then I start scanning through each of them in order to start substituting it into this particular script. My next step is use $ingress. I store the $value along with the scope. I check if the ingress is enabled. And if it is enabled, I then start storing these respective names. You get the chart name. This is nothing but getting the chart.full name by passing the parent template scope, which is dot, or the highest value, which is dot values, is getting passed in. I'm just getting the ingress path. The ingress path is required for the new format. So ingress $ingress path is required for the latest API version, which is networking.kh.io. You could, this is passing in the context of your respective web URL, which you could either have / or you could have multiple such options where you have multiple ingresses present. If you can see here, I have 2 separate ingress values. One is this and one is ingress path. And the third type is ingress path type, where I'm passing in what is the path type of ingress. So we have a couple of options in ingress where we can either use nginx as ingress, or we can use GCE load balancer directly as ingress. What we do there, we pass in the path type implementation specific or prefix. which are options available depending on the ingress type that you're using. The ingress type can be defined using an annotation or an ingress class. So in my case, I have directly used annotations where I'm going to substitute this particular value here into the respective annotations and embed my respective annotations into this particular setup. Whenever you start with a width or a range, you always have to end your loops. So if I have an if loop, I need to have an end to that if loop. If I have a range, I need to have an end to that range. So you always need to terminate your respective statements with an end when you start your respective thing. So here you will notice my with starts here. I have mentioned what to use. This is nothing but I'm passed, since I've created the variable of dollar values, I can directly pass in that variable here. Say go into dollar ingress dot annotations. Now the advantage of doing, I've used variables for one main reason, and that is, since I have an entire list of ingresses, say ingress-gcp or ingress-azure, I want to specifically go into that respective ingress and only pull the annotations for that specific ingress. So when I do use the variable value in range number 1, it will only go into ingress-gcp, pull out the annotations for ingress-gcp, and embed it into this respective application. Post that, I've converted it to YAML as previously explained, and then I indent it with 4 spaces. And then I terminate my with clause. Similarly, I have put in my spec, which is the Kubernetes manifest of what it requires. I'm checking if there is TLS enabled. If there is TLS, I have again put in the range and put in an end for it. So when I did pass in the range $ingress TLS, you can see one advantage of directly passing in the scope using the variables is I can directly access the inner portion of the scope without having to mention the whole $ingress.host, etc. So here, since I've done the dollar range, I can directly access the .hosts present in my values.yaml file within the scope of ingress.tls. So in my case, ingress-gcp, inside that I would have a TLS parameter, and whatever values are present for hosts inside that TLS parameter will automatically come in here based on this values I have provided. I'm quoting them since that's what you would want to do in order to use the ingress. Similarly, passed in the secret name. Since the scope is passed in using my variable, I don't need to re-mention the whole part, which is $ingress TLS. So what this translates to .host is $ingress TLS secret name or $ingress TLS hosts, which I don't need to access anymore since the scope gets passed. And finally, if you can see the range and all, you basically provide your $ingress hosts, etc. Whatever ranges we start, we have to end them or terminate the end. So the only once you perform that action, that ensures that this ends. Now, since you notice that I have created the for loop for the entire ingress, you want each of your ingresses to be split up into separate files. And that's why I'm printing the triple hyphen, which basically indicates that it's a new file which you're starting. So what I'm doing is ensuring that all my respective ingresses get split up into separate files and they get printed out accordingly as well. And I ensure that I end each of my clauses. So this end is for the if loop which I started here, and this end is for my range which I started here. So I think in the template which I've shared with you all, ingress.yaml is the most complicated file. The rest of the files are simpler to understand. They have very direct references of how we have used them. These can be modularized as well, provided you need them. I don't think deployments need to be modularized yet, but there could be a possibility that certain applications would preferably require the ingress concept or the multiple ingress concept also used for deployments or services, etc. So this is on a high level about how we can begin or jump into the world of Helm charts, where how do we use the Helm charts? How do we extract the names for Helm charts? How do we ensure that we can write functions for Helm charts? Brad, do you have any questions at this time?
There's no more questions in the group. We've got about 10 minutes left. I think that was quite deep for an introduction. Why don't, if you want to, we could quickly build one from scratch with just a simple Nginx deployment. That's it. And a service.
Sounds good. So what we can do is start from chart itself, and you can pretty much say this is the chart.yaml.
Yeah, so let's do one that's like the most basic vanilla Helm chart you can make. And I guess it's a key thing, you know, when I was learning, for example, I didn't worry about helpers because, you know, generally when you're doing simple Helm charts or manifest files, it's all done for you and you don't really need to go too advanced. And then also when all of this looks very scary when you're starting off. It's like, wow, what is all this? It's very overwhelming. So one thing that I did is I copied a plain manifest file for a deployment and a service. And then I just, as I learned, I would put another Helm chart on the other screen and just copy, okay, this is how I use values. And then I'm saying, okay, my image name, and I put values.image name. And I found that was the easiest way to learn Helm. Just start off very, very simple from scratch. And then as you start learning more about the values and it doesn't look scary anymore, then you go back and you add and you just keep continuously iterating on it.
Yeah. So I totally agree with you on that one. And Helm charts do look a bit scary at the beginning. But if we start covering only the portion of it, that should simplify our process. So let's get rid of Ingress. Let's just keep deployment and service. So the reason I provided the template is so that you all could leverage that template in order to reuse it and create your own Helm chart, where you'll keep on your end, you'll look at the old Helm chart and start creating your own new one. So let's call this Helm tutorial 1, where you'll are creating a new one, give a description, give the version number, app version. The next part is assume that you then require deployment. You do not need any of these functions. You have the option of directly providing the values inbuilt, which is dot values. And then you mention dot either deployment or however you want to provide your respective values.
And let's quickly put the values file split screen beside it, and let's look at how we reference those values. So you'll notice that in the values, we can see here we're using values.deployment. So it looks like we need to add that in. So values is just the file, and then this is YAML. So we put here deployment, and then let's say deployment name would go 2 spaces indented, and then that would be like demo, for example, whatever we want to put. And that's how you reference it. So this particular name would be referenced as values.deployment.name. And that's how you leverage the values. So what I did as well is when I wanted to, make it more parameterized, I would put the values on this side, the manifest file here, and then I would just and keep testing as well. You can either use dry run or you can deploy it and see if it's working. But this is a great way to first start off. Is you don't need to have all these crazy parentheses everywhere. Just be comfortable and slowly add them in, and that's how you can learn. That's how I learned anyway. I found it the less overwhelming with all of these things is better. Like that Ingress was quite advanced actually, so and you don't even need to have parameters. You could have a Helm chart just with no parameters if you really wanted to. So start small, and then you can slowly add them in.
Yeah. So assuming that doesn't really matter, heritage is automatically generated by Helm itself, where the heritage, it gets in the value called Helm. So if we deploy any chart using Helm, it automatically gets those values. This is basically nothing but a Kubernetes manifest. If you notice, it's templated format of getting values of Kubernetes. So this is just a deployment.yaml, which you'll find in Kubernetes, and you're describing that deployment with all the different values that you have. As a deployment has replicas, I have mentioned values.replica count. That can be 1 or 2 in certain cases. And post that, you don't need to have any of these values as well. Like as Brad mentioned, they can be as simple as .deployment.name. Change these to the format, and release name stays the same because release name is directly extracted from Helm and it's generated by Helm.
And we just have another question is from Praveen. Nice motorbike, by the way, in the picture. What are the best practices when creating charts? So
there are a couple of.
Okay,
Yes,
you
please.
go. Sorry. Okay, so best practices. One of them. Maybe I'll do one. You can do another. So one good practice is that you want this chart to be as dynamic as possible. So when we're making the values file and the parameters, we want this to be able to be used in multiple scenarios. So for example, dev environment UAT, like maybe in prod we have replicas as maybe 2 or 3, opposed to dev would be 1. So if you look at Artifact Hub, like they're so parameterized that anyone can leverage them. So I guess to me, one best practice is to make it as dynamic as possible with your parameters.
I completely agree. And to drive that point home, I would pretty much be having a separate. I would have one of this. Similarly, I would have another file called staging values.yaml. And the advantage of using this is when you do go down the GitOps rabbit hole, you will find that you do not want to do any steps manually. So everything should automatically be picked up by tools such as Argo or Flux. And in such a scenario, all the values that you want to push or pass by should be already present within your respective code base. So that's absolutely right. The other best practice, as Brad was mentioning, is the namespaces. So namespaces, as per Helm, should always be passed when you're installing it as a -n. There are some issues with doing that when you're using GitOps because Helm. So Helm also has the option. When I showed you all the chart.yaml, technically speaking, this also can hold a namespace field, but this is not best practice. This is like you're hard coding a namespace, which ideally shouldn't be hard coded. What you should be doing is you're passing in the namespace via a -n, And the limitation of that currently on Argo is that you since everything needs to be on a code based level, it does not support that. Like according to Argo, if it's not in the code, it doesn't consider it as a respective passed parameter, which complicates things. And that's one of the reasons I thought about using customize in that scenario. So never hard code values. All values should specifically for namespace, it should always be passed through using the respective command when you're firing it. And probably the third thing which I would like to cover is Helm files at scale, which is going into the best practices portion. So if you have more than one Helm chart in a single repository, in the sense a monorepo, say you have a cluster which you bootstrap, where you're installing all Kubernetes related infrastructure, you're not going to be firing individually all the Helm commands, right? So in that scenario, you're going to be using Helm file at scale. Do you want to talk about that, Brad?
Yeah, do we have a demo here for Helm file? Okay.
Yeah, we have a demo as well as this is the chart which I've created as well.
Okay, so yeah, for Helm file, we've been using this for quite a while, haven't we? So maybe a year or two. And what it does is, if you have more than one, instead of running Helm install on every chart, you can define all of your charts in the Helm file, and then that will install all of them at the same time, essentially. And the sync option is good because it generally just changes what you've changed in the chart. So yeah, maybe you can see here we're specified at the top the repositories. You can specify them all there, and that will download them all at the same time. And then so at the top you see repositories, and then when we see the releases in Harbor, we're just using the name Harbor because we've already pulled that chart down. And then you can see that here we're parameterizing environment. So like we showed before, we had different values files per environment. So therefore, keeping that parameterized here as well is we can choose which environment that we push to.
Yeah. And the folder structure you do in Helm file.d in Helm file is you have a Helm file.d. You put in your respective YAML file here. I have also shared that within the code base so that you'll have a reference for that as well. What you will notice here is I have given the option of using multiple Helm files. So here I've commented this out, but this is an example of how you would set it up, where you can just pass this and you can mention how many ever Helm files you have within this respective setup. So if you want to install it at scale for bootstrapping a specific application, this is the route I would go to. And this is something which I would always definitely pass when I'm trying to install a Helm chart. And that's so that if there is a failure on your chart, so there are times where we make changes and a Helm chart is going to fail after that. And we don't want it to bring down the whole application, but rather what we want is to only deploy it if it is a good deployment. And if it's a bad deployment, we want it to automatically roll back. And how we ensure that is doing atomic is true. One of the other advantages of your respective Helm file is if you do not have a namespace which is existing, Helm file creates that for you. You do not have to pass in any additional flags such as create -- create namespace.
Yeah.
You will also notice that there are times where something might not necessarily be in the main branch, where you can leverage hooks in your respective Helm file. What I have done here is validate, I wanted to install a specifically CRD, which is custom resource definition. It's kind of a starter pack for installing new applications. And when you are installing that respective CRD from a different branch, for example, I specifically downloaded that different branch files CRD and installed it as a hook using kubectl apply for this respective Helm chart. That was till it got merged to master or main. Once it got merged into main, then I could just delete the hook. I do not require it anymore. But if you do want to install additional stuff during preparation of your application, you have these options using Helm file. In terms of versioning, I would say best practices just use Semver. You can Google Semver and it basically walks you through how versioning should take place. Descriptions should be, there should be sufficient description to what your chart is. The configuration file should be present. So when you do create a Helm chart, if you want to give it to other DevOps engineers, etc., ideally, whatever configuration you want should be well described in a format similar to this, so that anybody who jumps on then knows this is all the configurations I do have, and this is how I can leverage them. Where you can see it's mentioning this is of string type, this is of list type, this is of object type. It gives someone a very clear picture about how I'm creating a Helm chart. Also does well for documentation if you ever decide to make that Helm chart public and you want to share it with a wider audience in the long run. Apart from that, I would say labels are important for a Helm chart. This is, I find it easier to overall retrieve respective applications. So for example, if you want to, you are in a namespace, you have multiple deployments, but you want to know what deployment was there with only this particular label, then in that case you can do a kubectl get all, but you can specify -l and the label name, and that helps us in extracting only the respective components that were installed in the respective Helm chart. So I would say that is an important best practice as well. These are just some of the ones, and I'm pretty sure like if you just Google best practices, you're going to have loads more options as well. So these are some of the ones which I keep on the top of my head when I start creating a Helm chart and modularize away.
Yeah, and just a little bit more on Helm Hooks. So the problems that it does solve is that if you don't have those Kubernetes manifests, it does give you the ability to, they have options like pre-install, so that will execute after the templates are rendered, before any resources are created, it will make it. And then you have post-install, pre-delete, post-delete. So it allows you to customize your chart even more, to solve those problems if you need to add, extra manifests that by standard people don't use.
Yeah. Especially when you're reusing someone else's code, there are times where you might say that you need an additional, say, ingress, but the respective Helm chart which is published does not provide that. Now, in this case, using the hook, you can actually install that ingress. And I think we encountered that for Captain, where Captain did not have an ingress by default. Is that right? And then you created the ingress separately.
Yeah, we went through different stages, didn't we? So the first one was a Helm hook, and then we decided to actually do a pull request to add the ingress, and then after we used customize as well. So that would be a good talk about the journey we went on that ingress one. But yeah, it worked quite well.
Absolutely.
Okay, that's time. Yeah, that's time up. So any closing remarks from you, Emma?
No, best of luck on your Helm journey. And definitely, if you have any help that you need or you have any queries, feel free to reach out to us on LinkedIn, Twitter, email, however you all prefer.
Yeah. Okay. All right. Thank you very much and have a good day, everybody.
Thanks
Cheers.
a lot, everyone. Take care.